It's been 24 hours. I need more hours with you. 5.1, polynomials. All right, so we get to start off this chapter with listing different ways to classify polynomials. Polynomials is just the equations that we've been working with, but with more degrees to them. All right, so let's classify these polynomials by their degrees. The degree of a polynomial is determined by its greatest exponent. So if we just have an equation with x, we call that linear. We've studied that in Algebra 1. It's just a straight line. Last chapter, we bumped it up to x squared. Those are called quadratics. This chapter, we're going to go bump it up even more to x to the third power. Those are called cubics. X to the fourth power, quartic. X to the fifth power, quintic. And then anything higher than the fifth power, we're just going to say that degree. So for example, x to the eighth power, we're just going to say it's the 8th degree polynomial. All right, so anything above 5, we're just going to call it the way it is. All right, you can also classify polynomials by how many terms they have. If a polynomial has one term, just like this, it's called a monomial. If it has two terms, we call it a binomial. If it has three terms, trinomial. And then anything more than 3, we're going to go ahead and call it a polynomial. All right, so the really long ones, we're just going to use poly, which means many. All right, let's go ahead. Let's do an example. This one says, write the polynomial in standard form, then classify by degree and the number of terms. So first we have to write it in order of exponents from least to greatest. There it is. I just rearranged it, keeping the signs the way they are. In this case, we have the exponent 5. So 5th degree is called a quintic, and there are 4 terms, and so we're going to call it a quintic polynomial. All right, so just classifying them. Let's focus on end behavior. So now, in calculus and pre-calculus, we kind of study things that go on forever to infinity. And so this is our kind of introduction to what happens at the ends of these graphs. What happens in the negative infinity and in the positive infinity. Okay? Like, for example, in Algebra 1, you studied equations with x's in it. They look like straight lines going this way. All right? We say the left side goes down and the right side goes up. That's what's happening at the ends of it. The right side goes up all the way forever, and then the left side goes down all the way forever. And then we threw in a negative in front of it, and then what happens? It switched around. The left side now goes up, and the right side goes down. Okay, so that's what you did in Algebra 1. Last chapter, we did x squared. These graphs were these happy faces. Notice the left side is going up and the right side is going up, so they both go up. What if I threw a negative in front? Then it made it into a sad face. And now the left side and the right side are both going down. All right, so when we talk about end behavior, we're talking about what's happening at the far end on the right side and what's happening on the far end on the left side. And you just have to say up or down. This chapter, we're going to study cubics. What do you think a cubic graph is going to look like? Okay, it actually looks like this. Like a little squiggly. But we're not entirely focused on the squiggle part. In this section, we're going to focus on what's happening at the ends, right here and right here. Notice the ends of this match the ends of this. The left side goes down and the right side goes up. So that's what we're going to focus on. Negative looks like this. Okay. And then notice the negative matches with this negative. The left side goes up and the right side goes down. What about x to the 4th power? It's going to look something like this. Okay. It matches up with the x squared because it's the left side goes up and the right side goes up. Negative x to the 4th goes down. Both sides down. And then if you've noticed, every time I add a number to the exponent, there's more inflections. And yes, the number of inflections does relate to the number of time the graph changes direction. Okay, like x to the 5th. You have to first think, okay, what does it look like in general? X to the 5th in general should look like this. Left side up, left side down, right side up. If you were to actually graph it, it would look like this. 1, 2, 3, 4, 5. Okay, so there's inflections inside, but for now, again, we're only focusing on what happens at the ends of it. Negative x to the 5th, in general, is going to look like this. Left side up, right side down. X to the 6th, what do you think? In general, it's going to look like a parabola, a happy face. In reality, it's going to be 1, 2, 3, 4, 5, 6. Okay. A negative x to the 6th, in general, is going to have both sides down, down. So let's take an overall picture and see what happens. What if I asked you, what is the end behavior for a negative x to the 35th power? So then you have to think, what does it mimic? Which of these original ones is negative x to the 37th power gonna look like? If you said negative x, you are right. It does look like this. Okay, the right side goes down, the left side goes up. And if you were to actually draw it, there would be a whole bunch of bumps in there. I'm not going to do 37 bumps, but it is a lot. Or what does x to the 100th power look like? It's going to look like the x squared. It's going to go up and up. And then a lot of inflections in between. Okay? So let's come up with a general rule. The rule is when you have an odd exponent, if the number is negative, it's going to look in general like this. If it's positive, in general, it's going to look like this. For even exponents, if it's negative, in general, it's going to look like this. And if it's positive, in general, they're going to look like that. All right, so keep those in mind. Let's analyze this. classify the function by the terms. It is a trinomial. It has 3 terms. And by the degree to the 3rd power is a cubic. Describe the end behavior. All right, so let's look at the highest degree. It's a negative and it's odd. So in general, it's going to look like this. A negative odd. On the left side, it goes up. On the right side, it goes down. Now, those brackets are not like the official way to write it, but for this, we're going to go ahead and write left side up, right side down. Find the turning points. All right, so this is when you have to use your graphing calculator and graph it. I did this on Desmos. This is what the graph looks like. The turning points is where the graph turns around. Here and here. And Desmos easily gives you those points at negative 0.577, negative 0.155, and 0.577, 2.155. All right, so those are the turning points. You have to find the intervals of increasing and decreasing. Where is the graph increasing and where it is decreasing? All right, so if you look from here, it goes downward, reading from left to right. So that's decreasing. The way you write that is from negative infinity, all the way in the negative infinity, all the way to negative 0.577. It's actually this point right here. Negative 0.577. All right, so that is decreasing. Now, knowing this part right here is increasing, so it's going up. The way you write that, decreasing, is from negative 0.577 to 0.577. It's these 2 points. We're only looking at the x values. That's increasing. And then from here to here, it's decreasing again. And the way you write that, from 0.577 to positive infinity, we have increasing. All right? So, moving on. T-tables. So I think the last part of the homework, they're going to give you a table and they're going to ask you if you were to graph this, what degree of the polynomial is this going to have? All right. And so to do that, you first notice that all the x's are in order from -3 to +3. Make sure that's the case, otherwise this won't work. Okay, once the x's are in order, let's analyze the y's. We're going to look at the first 2 y's and we're going to subtract. We're going to take their difference. -7 minus a -1. All right, and that should give you -6. And then we're going to continue that whole process. -3 minus a -7. And that gives us 4. And then you keep going down. 5 minus a -3. That gives us an 8. 11 minus 5. That gives us 6. 9 minus 11. That gives us -2. And then, of course, -7 minus 9. That gives us -16. All right. Guess what we're going to do now? We're going to do the same thing for the next row. 4 minus a -6 gives us a 10. 8 minus 4 gives us 4. 6 minus 8 gives us a -2. And then -2 minus 6 gives us a -8. And -16 minus 2 gives us -14. What is this telling us? Nothing yet. So we're going to keep going. 4 minus 10 negative 6. Negative 2 minus 4, negative 6. Negative 8 minus 2, negative 6. Uh-oh. Negative 14 minus the negative 8, negative 6. So it turns out that their differences is negative 6. Their third difference. So we had to do this 3 times to get them to be the same. So that tells us that the degree for this polynomial is going to be x to the third power, just because we had to do it 3 times. All right, so that's kind of fun. Cubic. All right, this is the last slide for the day. It's a long lesson today, huh? Analyzing the graph, determining the sign and the degree of the leading coefficient is the last part of your homework. All right, so it's basically going backwards. So yeah, earlier I gave you the function and you had to say what the graph looks like. Now I give you the graph and you have to tell me the sign and the degree of the leading coefficient. All right, so if you look at it in general, looking just at the endpoints, what's happening? You have the left side going down and the right side going up. So in general, you have something that looks like this. That means that it's going to be a positive function. Now let's count the inflections. We start off with 1, switch 2, switch 3, switch 4, and then finally switch 5. And so this is going to be a positive x to the 5th power. All right, that is all we have. Hope you guys enjoy the homework.